By the name of God, most merciful, most kind, peace be upon you all. Our subject of today is partial pivoting, but this time for 3 by 3 matrix. We are going to talk about the solved problem 216, find LU matrix for PA, and there is another solved problem 217 for the same A, but this time we will find out the unknowns x1, x2, x3, but perhaps maybe in another page. We'll move to the second slide. We refer to numerical analysis book, and the professor is the author, Professor Timothy Sauer, under the item 2.43 PA equals to LU factorization. Once we have moved any row or making swap from row to row, the A matrix is no longer equal to LU, but the swap will cause the A matrix to become PA, and in that regard, PA equal to the LU. And that process is called partial pivoting. And the author is saying the PA equals LU factorization is the established workhorse for solving systems of linear equations. I quote, under partial pivoting, the rows that need exchanging are not known at the outset, so we must be careful about fitting the row exchange information into the factorization. For the next slide, we have example 2.16 for the partial pivoting. The requirement is to find the PA equal LU factorization of the matrix. This matrix A is 3 by 3 matrix. We have 3 rows and 3 columns. And the elements of that matrix are 2, 1, 5, 4, 4, minus 4, 1, 3, 1. In order to apply the partial pivoting, as we know, this is our pivot 2. We are going to check what is the maximum value for A sub 2, 1 and A sub 3, 1. We have 4 and 1. The absolute maximum value between 4 and 1 is 4. Then we take the decision that we are going to swap the row that contains the maximum value for the left side element. We will make swap from R2 to R1. And of course, the first row will move to the second position. So our new matrix in that regard, it's no longer A, but it will become, or we will write it as PA. It will be 4, 4, minus 4, 2, 1, 5, 1, 3, 1. We could write the lower matrix L naught by dividing 2 over 4. We can write 1 over 2 as L sub 2, 1. We divide 1 over 4. We put it here 1 over 4 as L sub 3, 1. And keeping 1 as a diagonal based on the Dolittle's method, still we have L sub 3, 2. But we have to be careful because we are going to check whether there is another swap or not. If there is a new swap, then we have to multiply again by permutation matrix, and this will affect the final lower matrix elements, as we are going to see in the next slide. In order to convert 4, 4, minus 4 to 1, 5, 1, 3, 1 to an upper matrix, what we are going to do, we use this new element as a pivot. We will multiply by minus 2 over 4 R1. We add to R2. We place the value in the new R2 position. And similarly for the R3, we are going to multiply minus 1 over 4 by R1, add to R3 and place it in the place of R3. We are going to perform the operations to create a lower matrix. The first row is the same, 4, 4, minus 4, while for the second row we have minus 1 over 2 by 4 is minus 2. We add 2, a2, 1, it will become 0. Minus 1 over 2 multiplied by 4 is 2. We add to 1. Minus 2 plus 1 is minus 1. Minus 1 over 2 multiplied by minus 4 is plus 2. We add to 5, it becomes 7. For the third row, minus 1 over 4 by 4 is minus 1. We add to 1, we have a 0. Minus 1 over 4 by 4 is 1. We add to minus 1, and we add to 3, we have plus 2. Minus 1 over 4 by minus 4, we have plus 1. We add to 1, we have 2. L sub naught is the same as we have discussed. We change the sign. So we have one diagonal based on the Doolittle method. And this 1 over 2, again, this is becoming 1 over 4. And this is, we don't know so far. Now we want to proceed to have an upper matrix, so we need this element to become 0. But based on the partial pivoting, we have to check whether A sub 2, 2 and A sub 3, 2, which one is the maximum value. So we are going to select the maximum value of 2 and minus 1 in order to decide whether we are going to make swap or not. We'll find out that the maximum value of the absolute value of 2 and minus 1, we have the maximum absolute value is 2. Then we decide to swap the third row to the second row and vice versa. Then we will move to the next slide. In the next slide, we have 4, 4 minus 4, 0 minus 1, 7, 0, 2, 2 prior to the swap. Once we are going to swap, it will be written like that, 4, 4 minus 4, 0, 2, 2, 0 minus 1, 7. Based on that, we have replaced the second row by the third row. This is our new pivot. Then we are going to multiply minus by minus 1 over 2, R2, and add it to R3, and all the values will be in the new R3. Plus 1 over 2 by 2 is 1, plus minus 1 is 0, so we have 0 here. 1 over 2 by 2 is 1, we add to 7, we have 8 here. Hence we have come to find the final U matrix. And this is the remainder of the lower matrix L sub 1, 1, 1, 1, 0. This 1 over 4, 1 over 2, and we have one unknown L sub 3, 2. Now we can obtain that L sub 3, 2 by changing the sign of 1 over 2, the multiplier for the upper matrix. So the L sub 3, 2 is minus 1 over 2. We can write the final L matrix, 1, 1, 1 diagonal. 1 over 4 is L3, L2, 1. L sub 3, 1 is 1 over 2, and L sub 3, 2 is minus 1 over 2. We'll move to the next slide. Okay, let us check what are the operations we have performed. First, we have the A matrix. Then we make a swap. We have swapped the second row will become as the first row. From the left, we have multiplied by what's called P213. Instead of 1, 2, 3, we have 2, 1, 3, which means that the first row is the second row, followed by the first row, and then the third row. Then, while we change the pivot for, we make another operation, which we replace the second row by the third row. So from the left, again, we multiplied by B132. The normal arrangement is 1, 2, 3, but based on the 3 proceeded and before the 2. Okay, so this matrix, we call it as BA. BA is LU. This is the right-hand side, LU. This is the L and U, which we have already obtained. Let's check. This A matrix 2, 1, 5, 4, 4, minus 4, 1, 3, 1. This is the original matrix. B 2, 1, 3. The position of 2, which is 0, 1, 0 of the identity matrix, become first, followed by the first row originally of the identity matrix, that is 1, 0, 0, and the third row is, as we know, 0, 0, 1. Okay, what? 1, 3, 2. For the identity matrix, this is the first row, 1, 0, 0. It is in the same position, but the second row is becoming as 0, 0, 1. And the last row will be 0, 1, 0. Okay, let us arrange. We multiply B132 by B213. So 1, 0, 0 multiplied by this. This is first row by this one. This will be kept unchanged. 0, 0, 1 will bring the last row as a second row. So we expect that we have 0, 0, 1. And 0, 1, 0 will bring the second row as a third row, so we end with 1, 0, 0. Here again 2, 1, 5, 4, 4, minus 4, 1, 3, 1. Let us multiply L by U. 1, 0, 0 will keep this row as it is, 4, 4, minus 4. 1 over 4, 1, 0, it is a multiplier of the first row by 1 over 4, added to the second row. So 1 over 4 by 4, we have 1 plus 0, we have like this. And 1 over 4 by 4 is 1, we add to the second row, by 2 is 3. 1 over 4 by minus 4 is minus 1, we add to 2, we have 1. Okay, for this row, the last row, 1 half, minus 1 half, and 1, when multiply, 1 over 2 by 4 is plus 2, minus 1 over 2 by 0, and 1 plus 0, there is no quantity, so we have 2. Then 1 over 2 by 4 is 2, minus 1 over 2 by 2 is minus 1, 2 minus 1 is plus 1, then 1 over 2 by minus 4 is minus 2, minus 2, minus 1, minus 2 minus 1 is minus 3, plus 8 we have plus 5. This is the right hand side, 4, 4 minus 4, 1, 3, 1, 2, 1, 5. Let us check what is the final value of the left hand side. 0, 1, 0 will bring the second row up, so we have 4, 4 minus 4. 0, 0, 1 will bring the third row as a second row, so we have 1, 3, 1. 1, 0, 0 will bring the first row down, so we have 2, 1, 5. As we can see, the left hand side is equivalent to the right hand side, 4, 4 minus 4, 1, 3, 1, and 2, 1, 5. We move to the next slide. This is the finished elimination as based by the author. This is the L and the U as we have estimated. And this is a combined P matrix, which is B231. As an indication, this is the author. He said this is the final permutation matrix 0, 1, 0, 0, 0, 1, 1, 0, 0. But we have estimated as B132 by B213. This will give us the same solution as B231. And our estimated L and U matches with the author solution. We come to the end. This is another solved example, but we are going to discuss this example 217 in the next video. Thanks a lot. God bless you all and goodbye.